What's up, everybody? Welcome back. Today we are working on an Epoll based event loop. So the context here is I'm working on a web service where we are doing these like physics simulations, and we are allowing users to upload like environments for these balls to like roll around in, right? And right now we're kind of serving this all locally. Nobody's like, we haven't exposed this to the internet yet, but as soon as we do, there's going to be more than one user trying to view these things at a time. And with the way that it's set up right now, this is just going to fall over like pretty much immediately. So we're using Zig, and the Zig HTTP server in the standard library has this API that basically says, hey, I would like you to give me a TCP connection, and then you will like retrieve some information. Like somebody's going to say, hey, I have like an HTTP request to make, and we'll get the header for that HTTP request, and we'll do something with it, right? And so what we have right now is we just kind of like wait for the server, or our TCP server, to have like some sort of connection handshake, right? We say, okay, somebody's trying to connect to us, let's get that connection, and then let's handle that connection, and we'll spawn like an HTTP server, he's going to work with it, great. Now, this is going to immediately fall over as soon as we have one more than one connection, because, right, we basically say, hey, we're going to open this connection, and nobody else in the world can talk to us until we are finished handling that connection, which is pretty bad, but it's like extra bad when you realize that somebody might like open a TCP connection to you and just not say anything. And if they just don't say anything, we'll like spend forever waiting for the head of the HTTP request, and we'll just block all other users for the rest of time. So we need to do something to avoid that, right? You could like maybe time out on the TCP server if you didn't like have enough data come in over some period of time. You could maybe spawn a thread per TCP connection, and then that way they won't like interfere with each other. I don't really like those options because they, it's bad, obviously bad to just like block everybody for 60 seconds if one of your TCP connections stalls. A thread per TCP connection kind of results in like a lot of like OS overhead. You need to like context switch every time that you want to switch who you're talking to. You need to allocate like a 16 kilobyte stack for every single connection, which is kind of silly, and like we don't need that. And so there is this Linux API, Epoll, that basically says, hey, I have like a bunch of sockets that I want to listen to. Can you tell me when one of them is ready, and tell me which one it is, and then I'll like go do what I have to do with that socket and then come back. There's all other APIs for this too. There's like select and poll. I think epoll is just like a better, faster version of both of those. But the other ones are there for like POSIX compatibility and backwards compatibility and stuff. Yeah, so I think the plan for today is try to make like an event loop around epoll. What's kind of fun is if we do this right, we're gonna have like our main loop is gonna look something like, open TCP listener, right? So people are going to be like, say, hey, I would like to connect to you on port 8000, and could you please give me some data when I talk to you? So we're going to have like a listener that accepts sockets. We're going to like basically say, in our event loop, for every listener, add new connection. And then in our event loop, we're also going to say, for each connection, when get data, do something, right? And if we do this right, we can actually do more than just this, because like this event loop is going to be blocking the main thread. But you could also do things like use event fd, which is like a Linux file descriptor that says like, hey, somebody else can just say, hey, I'm ready to do something, which means that you could do stuff like promise chaining, where you can say like, okay, so I'm going to do this action, and when that's done, I'm going to do this action, and when that's done, I'm going to do this action. And if you like structure all this stuff right, then all of that comes for free. There's things like timer fd, which says like, hey, I want to do something in like 1 second. Epoll, could you tell me when that 1 second is up? And then there's also signal FD. So you can say like, hey, if somebody hits Control C on their keyboard, Epoll, could you wake up when that happens and tell me that happened? And then I'll handle that appropriately. So there's a bunch of stuff that this can be like extended to more than just TCP. And if we do it right, then like this is just a generic event loop, which is pretty nice. Pretty nice. So I think the plan is, let's try to like demo the failure case that we have in some way, right? Like I'm pretty sure looking at this code that if somebody just opens a TCP socket and then just says nothing, our whole web server will hang. But let's just like make sure that's true. Then we'll implement like the base case for Epoll. So we'll do like a TCP echo. You know, somebody we'll try to service like many connections of people that are just like typing to us, and we'll make sure that we can answer all of them from one thread. And then we'll have to upgrade our HTTP server to support working with like this interface. I think the Zig HTTP server doesn't really lend itself super nicely to it, but I think that like it has all the pieces that we need to do what we need to do. So that's the plan. That's the plan, and let's just start moving. Okay, so failure case. Should be. So wait, why is this read only? The fuck? Quit. Test Zig. Hello? Oh, I think it's fine now. Okay. So we should be able to say like function main void, and we should just be able to open up a TCP socket. So we'll use standard library, import std, and we have like std net TCP connect to host, connect to address, connect to host. It's fine. Localhost, and I think our service is on port 8000. This is probably failable. Yep, it can fail, and we need to give it an allocator as well, which means that we need an allocator. So we say our general purpose allocator is from std heap general purpose allocator with an empty config, because I don't give a fuck. And then we say at the end of this block, we want to deinitialize this guy, and he's going to return something, so we have to ignore it, and then we get like the allocator interface out of it. Boom, chilling. So here we should say this is our connection. And I think that if we just like while true sleep for a little bit, you know, for like a second at a time, I think a billion nanoseconds a second. I think that if we do this, we should see our web server hang. GoPro slow yo. Thank you for the raid. What's up, you guys? We are working on an event loop. Epoll, Zig, Epoll event loop. We set our buzzwords, and now we can keep moving. We're just demoing a case where our HTTP server, for our little app that we're working on, for our little app that we're working on, basically tries to handle all connections serially. That's a problem. So if we need to find some way to asynchronously handle events, essentially. Still working on the video editor. It worked well enough for me to try using it. And then as soon as I tried using it, I realized that every cut down of my VODs that I was going to make, I wouldn't be happy with. So I just immediately stopped because I was like, I don't care anymore. So apologies if anybody actually cared about that project, but you know, it's on the back burner for now. Okay, so I think that if we run our server, Zig out. We should see that if we run our test Zig, this will open up a TCP connection and just immediately die, but instead it doesn't compile. Of course not. Why would it compile? It never compiles. Foreground? Where the fuck is this thing open already? God damn it. Pub. Okay, Zig run. Okay, so I think that now if we try to curl localhost 8000, I think it should just never return. Yeah, and then if I kill test.zig, this will... Oh, I need to index HTML. So this gets our index. I run our little test that says, like, I'm going to open up a TCP socket. I curl again, and he's like, never answers, man. Never answers until I kill our thing. Then he's like, oh, okay, I'm good to go now. Yeah, so pretty clear that our fucking server's broken. Pretty clear. And it is clear that we need to do something about it. So, let's do something about it. Let's see, what do I want to do here? Maybe we will just start and make an event loop Zig. And maybe for now, we will treat this as its own file, like its own executable, I should say, and try to get something out of it. So let's add it to our build system where we can just kind of create a new executable. We'll call this event loop test. He is going to be called event loop test, and he's going to come from source event loop event loop. Okay. Event loop zig. And then we will say install this thing, please, so that we can actually run it from somewhere. I think we should be chilling. So if I go in here and I say like std debug print hello world, we should see something printed, except we have no standard library. So const equal import std, chillin, and zig build. Looks like he's maybe happy, maybe. And zig build and zig out bin event loop test. Okay, we see hello world. We are chilling. Everyone's happy. Okay, so what do we want to do here? We want a TCP echo server, which means that we probably should read the Epoll docs. How the fuck do we use this thing? So we say what? We like create an Epoll file descriptor, which I guess we get from the kernel. We then say, hey, we have events we want to listen to, and we want to listen to them for this specific event. Oh, this is EV events. Where does EV come from? EV is an Epoll event. And he has, oh, I see, we have EV as well as events. These are both structures of Epoll events. We create one event, I see. And we say, hey, Linux kernel, yo, could you please register this socket as something that I want to listen to, and I'm listening for this like input event. So like when somebody sends me some data on the socket, wake me the fuck up. And then we just do our little for loop and we say, hey, Linux, could you tell me when any of the events that I've asked for on this file descriptor happen? Right. And then he will give us those events in events. And then we just iterate those things and we say, hey, this file descriptor is this socket, so we know that we can like do these things. Otherwise, like we might want to do something else. What we do depends on the socket. Right, I think that makes sense. So we've got like Epoll file descriptor. We have like TCP file descriptor. We kind of like inject this guy into here, so he's got a kind of handle to him, and then we wait on this with like a list of Epoll FDs. 1, 2, 3. And if we had like, you know, TCP2 here, he would return like 2 things or 1 thing, depending on how many things happened in this like frame, we'll call it. Straightforward, nothing too crazy there. So we can say like Epoll FD. Fuck, how do I want to like lay out my windows? Because I kind of want that man page to stay open. Let's do this. Man Epoll. And we'll just kind of scroll down to their example. And this comes from probably on Zig. It's in like std POSIX or OS Linux. Looks like we have Epoll here. Sick. He wants events. I don't know what these events are, but in the example they wrote 0, so I'll write 0. What are these flags? Let's see. I guess we could look at the man page. That probably makes more sense. Man to Epoll create. It'll tell us what the flags are. Because I'm curious now. I see. Close on exec. Close on exec. What is this? CFD close exec. Where does that come from? Man to close. Close exec. I assume that this just means like something's gonna auto clean up would be my guess. In open, sorry. Man to open. Close exec. Close. Really? Oh, there's no S in clo exec. Of course not. Close on exec flag for the new file descriptor. Specifying this flag permits a program to avoid additional FCNTL operations to set the FD closer. Okay, what does it do? Because using a separate blah 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 does not switch blah 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 blah. Okay, but what is this? Sick. Can we just Google it? I feel like we should know. What does it do? Auto-close the file descriptor when you execute the child is inherited. Oh, that makes a lot of sense. Makes the file descriptor so close automatically when we fork. Yeah. I gotcha. So I guess we don't really care because we're not fucking forking. Maybe we should care. I guess it was a reasonable default to turn it on. But fuck it. Wrong window. Not main. We are in, what do we call this? Epoll event loop thing? Okay. So we'll leave it as 0. Man, Epoll. What's the next part of their example? So this might fail, except probably Zig is automatically converting the error for us, so we can assume that if this succeeds, that we're good to go. We can then just do, like, register an event. So we'll say const, how do they make the event? They just write struct epoll event. So we'll say const event is equal to std, POSIX epoll. This comes from Linux. Okay. Epoll event here. And this has events and data. So events, they are saying we use epoll in. So in Zig, that's probably going to be in like std os linux epoll in. Nice. Okay. And data is, this data, I guess, is a union, I guess. Yeah, so this is a union where I can say like, hey, there are many things that I might want to listen for, but in our case, it's a file descriptor. So data equals an FD of some file descriptor that we actually don't have yet. So we'll call this TCP socket, which we integrate. So TCP socket is std net TCP server. Yeah, here we go. Where does this come from? Server, how do I like make one of these? I think it comes from an address, if I remember correctly. There's like a listen on here. Yeah, nice. Yeah. Okay, so I go const server addy is std net address init IP4. Okay, and I want to listen on like 0 any address and port. What we're using 8000 was our other test. Is this available? Nope. Then we can do something like server addy listen with some listen options. For now, we will say nothing, but we will probably regret it later. And we'll call this a TCP socket or a server. And then here, we're going to say that we want to use the TCP server's stream handle, I assume. What is this thing? Yeah, I32. We're chilling. We are chilling. Okay, before we do this epoll stuff, actually, let's just make sure that we can, like, write an echo server without epoll. So let's just say, like, while true, TCP server accept. So connection is equal to this. And then how do we use this thing? This is a connection, yeah. How do I wait for data on this thing? Connection stream read. Yeah, okay. So while connection stream read, so we'll read into some buffer. So this is like a bunch of U8s. And is it this way? It's 1024 U8 like this? I can't remember. We'll read into the buff. We'll say read bytes is equal to this. And then we look at buff 0 read bytes and we send that shit back. With write all. There we go. I think that what we want to do here is we want to do, this will like error out, I think, if they close the connection. So we should just be able to shove all of this in a function that says like we echo based off this connection, which is a studnet connection. No, what is this thing? Server connection maybe? Yeah, server connection. Maybe you could use FIFO pump. I probably could use FIFO pump, but I'm not really convinced that I like that more. It feels like more work than just doing this, to be honest. So we'll just say echo connection. And this will go in a loop. And so this should exit out as soon as somebody disconnects from us. And so here we can just say catch, do nothing, and go again. I guess maybe on catch we'll say bye-bye. Okay. So if we run this thing now, we fucked up. Something is const when he doesn't want to be, so this is variable. He's still unhappy because I need to coerce the buffer by throwing a little ampersand in front of him. He doesn't want to be const either because I'm trying to write to the buffer, of course. He doesn't like that this thing can fail, and this thing can also fail. Looks like we're chilling. Okay, so now if we go over here and we say like telnet localhost 8000. Why would I have telnet installed? Why would I? Why would I? Hello? Smiley face. Okay, so we are seeing things printed again, which means that he's sending it back. How do I quit? Quit. And then he didn't say bye-bye, which is not good. And he's not answering anymore. So why didn't he quit out? That's not good. I would have expected him to quit out here. So stood debug print waiting. And here we'll say got some stuff. I'm assuming that this just isn't failing like I thought it would. Yeah, hello, hello, and then quit. Oh. Yeah, so now he's just like hot looping. I guess we'll say if red bytes is equal to 0, return is probably the case that we missed here. Hello, goodbye. No? Oh, I see. He's not saying bye-bye because it didn't fail. So here is what we should do. Okay. Hello. Quit. Oopsies. Telnet. Hello. Why isn't he saying goodbye? What the fuck? Am I high? This should happen. Am I fucking crazy? Stood debug print new connection. Not that this matters. This isn't really related to what we're doing. But I just want to make sure that we get it, you know? Error in use, fuck off. So here we can just say reuse port true and reuse address true because I don't give a shit. Hero Dev, thanks for the raid. What's up, you guys? What is up? Address in use? Really? Shouldn't he be totally fine with that? Because I said you're good to like reuse. This is on listen, reuse port, reuse address. Yeah, what the fuck is the problem? What is the problem? Do I have to like reuse port, reuse address? Oh, there we go. He's fine. Okay, waiting for connection. Telnet. Hello. And then I say goodbye. There we go. Okay, cool. So we've got our little. The previously open socket wasn't good to reuse, so it doesn't let you. Oh, that's right. It's for the next time, not this time. Right. Okay. So we've got our little TCP server that lets us, you know, talk to it, and we use echoing back. So we've proved to ourselves that we know how to write that. So we can go back to writing our epoll stuff. So what is the plan here? We go back to man epoll, and let's look at what it tells us to do. Right, so we now ask it to monitor for this event. So we just say std posix epoll ctl. On our epoll fd, could we do std os linux epoll ctl add? Yep, and we add our socket, which is our TCP server stream handle. Yep. And then we give it our data. Okay. Chillin'. Do I need to give it the data? What is this data for? I assume that if we are giving the handle here as part of our like epoll thing, it's not actually looking at this file descriptor internally. And like the fact that this is a union that lets us give it whatever we want, probably this is for us, right? So when he finds an event, he'll like give us back this number, and we could do something like give it a pointer to some like user data that we want to use to handle this request or something. But for now, we'll just do what they did. Yeah, for now, we will just do what they did. Okay, so now we shove our while loop in here. This is probably failable. Epoll CTL. I'm assuming that Zig's standard library is doing a nice thing for us. Yep, chillin'. Cool. Why is this optional? Man epoll CTL. It does think it's nullable. System calls you to add, modify, or remove entries in the interest of... Oh, I see. So maybe if I'm not adding an entry, then that thing doesn't matter. Would be my guess. Yeah. So on delete, it can be null. But on add, the entry includes the file descriptor, file unit reference to an open file descriptor, blah, blah, blah. Yeah, okay. Man epoll. We go back to our example. Epoll, wait. Right. Okay. So while true, we wait for some events. So we say const number of FDs is equal to std posix epoll wait. Given our epoll file descriptor, events as a slice and timeout. So here we're going to have like var events is a bunch of std os linux epoll event. And let's say that we can do like 100 of them. Then we can pass in events here. And then what was the other thing? Timeout. 0. -1, sorry. -1. We will wait forever and ever and ever. This is almost certainly failable. No, it's not. Okay. And then... But he does return a usize. Very strange. Why? Yeah, that's very strange. I would think that we should just return an error here. Very weird. But we could always, fall back onto the Linux implementation, which gives us errno values, and then we can handle this ourselves if we need to. But for now, we will just do what they do. Okay, so for events from 0 to num FDs, we have some event. And they basically just say, hey, if we see an event on that file descriptor, we accept it. Yeah, sure, okay. So we just basically do whatever we were doing in here, down here. So we accept, and then we echo. Now, the problem here is this solves the like listening for multiple people, but like since we're only listening for one thing, we're not actually going to handle this shit asynchronously. Hold on. Let's call this listen event, and then we can name this event here without a problem. And here we are just going to say stood debug assert that the event dot data dot fd is equal to the TCP server stream handle, because it shouldn't be anything else right now. But at the very least, if we run this and it works, then we know that at least Epoll, we've registered the handle correctly and it's waiting. We're waiting at the right time. We'll have to like handle like dispatch to the right area of the code later. But for now, let's just run this and make sure that it works. So he doesn't like the listen event here needs to be mutable, I guess, is what he's saying. He doesn't like that the events thing is not a slice, but it is an array, which are very slightly different. Do you really think that async is useless if you use Epoll? Yeah. I mean, that's not really what you said, but you get the point. I think that the longer that I write code, the more that I think that we should remove abstractions. Like to an extent, right? Obviously, you need abstractions in order to like function, right? But I think that like the async abstraction in Rust was kind of a mistake. Well, not a mistake, because obviously the people who made the abstraction wanted to do it. But if I were to design Rust, I wouldn't make that async abstraction. Right? Because you end up needing to understand that there are like event loops anyways. You need like an executor, which is essentially just what we're making right now. You need to like all of your like TCP shit gets like tied to whatever engine you're using, which is like a problem. You have like the behavior of the async code isn't really necessarily what you would expect. I don't really think that the abstraction really works, right? Like in Rust, like the async abstraction is like pretty rough, right? Like it just your lifetimes are a problem. Your like types become like really messy. I'm sure that like I guess like in Zig that those problems wouldn't necessarily happen, but like I don't really understand what it even really provides, right? Like what's wrong with me just submitting things that I want to happen in sequence to a queue and like connecting them together? Like I don't really see like a reason why I need the extra abstraction, right? So do I really think that? Like I think I do. But maybe we will implement it and we'll be like, wow, we're really missing out on something. In which case we'll fix it. We'll fix it at that point. So if I telnet here, he is in fact still echoing, which is good. So now we need to basically say that when we get a new connection, we want to add this to the Epoll queue, right? And then instead of handling this echo while true like this, we want to like take this while true out and make it so that this echo callback is called when we get a Epoll event for a given file descriptor. So maybe what we will do is let's try. I'm pretty sure. Maybe we should read the docs actually. I think that I can just put whatever the fuck I want in this data field, which makes me think that maybe we could give a function callback that we want to call as like a pointer. Maybe we'll need some like data associated with it as well. But we'll see as we go. So yeah, the action that we want to, I guess we'll say that when we get an event, we will just call. Sorry, just let me think. 1 second. So we can't just like give any old function pointer to the Epoll event system, because like the pointer loses its like typing info. But we could give it any old function pointer that conforms to the same API. So we could make it so that we have like const Epoll callback is equal to a pointer to a function that takes in one any opaque. Like this. Any opaque. And I guess maybe we'll say it's a nullable any-opaque. And then we need to say that this will return nothing, right? Then we can say that we will cast the pointer fields of this thing. So we'll say event data pointer. We will cast this to an Epoll callback. So we'll say like callback is equal to this. Yeah. And this will have to align cast and pointer cast, but we'll, so that it does the right thing. Okay. And then we will call the callback. Easy. Now we need to make sure that when we register this, we do the right thing. So on each TCP connection, what are we going to do? I guess we'll just try writing a function that accepts the thing and registers a new Epoll callback, and then we'll see how, like, what needs to be done there. So we'll say this is like accept TCP connection. We are missing, we need to pass in some user data here. Probably. Any error void probably is return type so it can fail. Yeah, that's not a bad idea. But we will upgrade as we go. We will upgrade as we go. So yeah, where does the data that comes with the thing go? I guess instead of this pointer being directly the callback, we'll make it a callback with some user data. So we'll say a const Epoll data is a struct, and he's going to have some data, which is a void star. Sorry, star void in this language. And his callback is going to be an Epoll callback. Now, we can probably, I think we can stack allocate this thing. That's fine. So we just kind of say here, we'll have a const listener data is an Epoll data. And he's going to have the callback is accept TCP connection. And his data is just going to be null for now. Void, maybe any opaque? Right, in this language I write any opaque, not void. C brain. Thank you. And then we are going to make our accept TCP connection thing here. What do we call it? Connection. And we're going to take in our like user data. And figure out what the fuck to do here. So here we just need to call like, we need to extract our TCP stream from this thing, or whatever the fuck it's called, TCP server. So here we're gonna have like server is stood net server. This is a mutable pointer to a subnet server, which comes from pointer cast, align cast, user data. And then we just say server accept. So this is a connection. And then we're going to have to register this connection with our Epoll system. So we are actually, this user data is going to have more than one thing in it. It's going to have the server, as well as, this is going to have the server, as well as the Epoll file descriptor. Which means that our TCP connection accept door. Let's do this. Yeah, I kind of like this. So we'll make this like a struct that has a reference to like Epoll data. Epoll FD is an I32. He's going to have a server, which is a const stood net server. Maybe it's actually immutable. And then this is going to be user data. We're going to say const self is TCP connection acceptor cast from self, or from the user data, sorry, from the input. Yup. And then we're just going to call like self. We have self server, we have connection. So const connection is equal to self server connect. And then we say Epoll stood, where is it? We've already done this somewhere. We we create our event and we shove it into the Epoll system for this connection now. Yeah. Yeah. So this is going to have to do echo, right, at the end of this. That is what we're going to call, except this isn't, we don't want to give it a function, we want to give it a Epoll data. So we're going to say const connection data is a Epoll data. We have to actually allocate this thing somewhere because he's not going, like if we just feed this Epoll data here, like this function is going to finish. This Epoll data is going to go to scope and it's going to be pointing to invalid memory when we call it back later. So we actually have to allocate this thing, which means that we need an allocator here. Which means that we need to import allocator is equals std mem allocator. It's all coming together. You know, this feels like it's going somewhere. So we'll say alloc create. Can you just put self equals TCP connection acceptor in the declaration? It would cast it from any opaque when it's called compiled. I think no, because well, I could be wrong. I'm not sure. Because I would think that when we call here eventually later, or I guess when we cast it into the Epoll callback here, maybe you could do some sort of clever pointer casting to get it to work. But yeah, I think that that's worth trying because it would be nice if we could do it that way so you can avoid this cast. But we'll have to maybe I'll save that for a second step because I don't want to bite off more than I can chew right now. You are make a game. No, I don't know if this is a question, a statement, if it's like an instruction, or if you want me to be a make a game. You are make a game isn't even like you make a game now. It's like you are make a game. It's like no. I'm Mick. Hello. I don't know how to respond to that, so I'm just gonna stop. For now, we don't really know if we have. I don't think we have any data to associate with the echo response. But the callback is going to be echo. Echo, echo, echo. This isn't going to compile, but that's fine. We'll fix it as we go. This guy is going to. This is not how this works either. This create takes in a type, so this is going to create Epoll data like this, and then we say connection data dot star is equal to this. Yup, this needs to be try probably, and this doesn't have a break or a parenthesis on the end. This guy's not happy about these commas for some reason, which is surprising to me. Maybe this needs a dot here. There we go. Isn't Ball's simulation kind of game already? It's kind of a game. Yeah, it's like kind of game-ish, but you're right that I guess we are kind of working in that, even though that's not technically like that's not the topic for today, but the topic for today is tied to that, so maybe we are make a game. And I apologize for saying we aren't make a game. Okay. So here we need to register connection data connection stream handle. Here we have the event. We will just call it event. It's no longer a listen event. And I think we're chilling there. That feels like it's right. Game without a goal is not a game, but a toy. I think that's like a pretty wild distinction. I think that like, I don't know, yeah, you could make the distinction. I don't know that I would say that toys are not games or games are not toys. But also I don't really care, so I'm just going to stop thinking about it. Okay. So that looks like it's all right. We have nothing that's like closing the connection, but we'll just kind of think about that later. Fix me close connection, question mark, question mark, question mark, question mark. And there's no allocations associated with that, but that's fine. But we do have to like free this connection data at some point. So we actually probably need to listen. I wonder if there's like an Epoll event for like closed. But we'll get there later. We'll get there later. Let's not get ahead of ourselves. This echo function needs to follow the same convention. So he's going to take in a user data, which is a any opaque. And we said that our connection data is this. But we give our data null. Right, so we're going to be taking the data field of this guy and feeding him into this function. So he will be null, so we can just discard him. But that's not true. We need something because we need the connection. So let's make I guess let's make a struct for this guy as well. That feels like it makes sense. So this is going to be like a TCP echoer, somebody, a guy who echoes. And he's going to have some sort of state associated with him, which is the connection. So we'll say connection is a studnet server connection. Yep. Seems reasonable, which means that here we want to create one of those guys. So we'll say our TCP echoer. This has to be allocated as well, maybe? I think it does. Const echoer is equal to TCP echoer. Nope. Try self alloc create TCP echoer. Which means that here this can fail, so we need an error defer free on this guy. We create our echoer and we assign him some data. So we assign the connection is equal to connection. Chillin'. All right. So we don't lose anything here. This data gets the echoer now. Callback is echoer TCP echoer echo. Chilling. I guess we should probably error defer here as well, just in case. Self alloc free echoer. Boom. This is destroy, not free, actually. Free is for many elements, destroy is for single element. Okay, so now we have a connection that we can work with. So we can say self connection, but we need to make self. So self is a pointer to a TCP echoer that comes from a pointer cast alignment cast of our user data. Chillin'. Okay. Now, nothing is getting freed anywhere, but I'm not going to give a fuck about that right now. How do I become 1/8 the programmer you are? That's a nice thing to say about me. But I think, like, just keep coding and you'll get there. I don't think that, like, I'm anything special for somebody who's been coding for 10 years, right? Or more, right? I've been programming for a long time. So yeah, program for 1/8 of the time is like a great answer, right? You'll get there. I guess, I should be clear and say that I think that it's possible to do something for 10 years and still suck at it. But I think that with, like, focus, that shouldn't happen, right? As long as you just, like, keep poking at stuff and keep trying to understand what you're working with, you will eventually build up more context and more knowledge, and that context and knowledge will help you make decisions. So I wouldn't worry about it. Just put in time and make sure that you are trying to understand stuff. It's simple. Okay, so we need to make our TCP connection acceptor down here. So var accept TCP connection acceptor is equal to TCP connection acceptor. Here, I think that we are happy to live on the stack because the Epoll stuff is happening in the main thread. He needs some stuff, so we will give him some stuff. He needs an allocator, so this comes from here. The Epoll FD, I guess that means that this has to come down here when we have an Epoll FD. So this is equal to Epoll FD, and the server is equal to the server. We need an allocator, so we need to actually say that we have a... we did this already, didn't we? Oh, we did it in test.sig. We will copy paste this because I don't want to type these 3 lines of code, but we need to make an allocator. Boom, chillin'. Big chilling. So we need to use this guy, except store, not OR, not ER, and the data is the TCP connection acceptor, and the callback is TCP connection acceptor, accept TCP connection. This guy gets the listener data now here. And there's like a non-zero chance that this does what I want. The data, the callback here, this isn't cast to an Epoll callback. This should be cast to an Epoll data. And then we call data callback with data data. Yeah. That could work. I don't think it will. I don't think it will compile. But if it did compile, maybe it would work. And I don't think that'll work either. Okay, local variable is never mutated at line 70. So this gets a const thrown on him. Expected type net server found net server. Oh, so this actually should stay the way it is, and we should just put an ampersand like this. Boom. Echo is the wrong function type, right? So we should, on this guy, write any error, because it needs to, it's, if you just write exclamation point here, Zig will be like, let me look at all of the error types this thing can return, and I'll throw that on top as like part of my type signature, which is really great. But we actually want to like intentionally ditch that information, because we are using this as like a generic function that is implemented by multiple people. So if we throw any error on there, that kind of like type erases it, I think is what it's called, type erasure. I've seen that term used in C++ a lot. Expected use size found pointer at 101. So that is because the pointer is in fact a use size, and so we can just do int from pointer. Boom. And that'll probably happen in a couple places. So dot pointer equals, where's the other one? Int from pointer. And connection data is a pointer, so we're chilling. And pointer cast, line cast, expected pointer type found this thing, so this is at 112. Right, so this has to be a const, I guess, pointer, like that. Expected pointer found use size, so here we have to do the inverse, so pointer from int. And I guess, can we, like, delete this pointer cast, line cast then? Because it'll figure it out. Error union is ignored, so this has to be, maybe we will catch here and log the error instead of just like full on exploding. So we'll say stood log error failed to run callback due to some error. I guess it would be nice to know which one it is, but we don't know, so get fucked us. Okay, he builds, he runs, and telnet, hello. Oh, hell yeah, motherfucker. He sent it back. Woo! That feels so fucking good. Oh, I love it. It's so sick when it just works. He's spamming waiting there, so what's going on there? We don't need to do this. Oh, here, okay, so here we need to unregister the thing when he dies. When we are done, we need to say, hey, Epoll, I'm done, man. So the unabstracted way of doing this would be we take the Epoll FD here, and we basically just unregister ourselves. So surely that's like probably CTL del with our connection stream handle and with no event data. Now if we do this, fuck. We still actually want this stood debug print waiting here, so that we can see the failure or see how it fucks up, like if we make a mistake here. We are missing struct field epoll fd, so when we create this TCP echoer, we can just say epoll fd is equal self epoll fd. I think this is where it goes. Nope, at line 20. Oops, wrong spot. Wrong spot. Okay, so now when I telnet into this guy, and I say hello, he says hello back, great. And then I quit this guy, and this waiting log doesn't start to expand anymore. And I tell him again, and I say hello, and he's like chilling. That's super sick. Super sick. Yeah, okay, that's actually not too bad at all. We are definitely missing some stuff. Let's just double check here. If I uncomment this thing, we should get back into the state where it's like fucked. And when I quit this telnet thing, yeah, he just starts spamming. So this was in fact doing what we expected it to do. Yeah, it's pretty sick. Yeah, so what's going on here, just for a recap for those of us who have not been here the whole time or have maybe not been following along quite all the way because I'm moving quick and not really explaining things. Epoll, we construct an Epoll file descriptor. We say, hey, Epoll, I would like to register this file descriptor with you. And when you find some data, please like give me this event. And in this event, we like stash some data in here where we say, hey, I'm a TCP connection acceptor, which is like a function, like a struct that we've created that has a function callback on it. We say, hey, when you Epoll, when you find something that happened, somebody is ready to talk to us, tell us what we gave you. So we gave you this data here, this listener data, and our listener data says, hey, I would like to call this function with this data. And we call this function with this data, he accepts a TCP connection, and he does like the same registration, except he registers the new TCP connection with this guy with a new data. This new data is like, hey, I am a TCP echoer, and when you get an event, could you please like call my echo function with my data? And then in there, we do the same thing, where Epoll will then like be like, uh-oh, TCP connection got some data. I would like to, you want me to call this function? I'll call this fucking function for you, man. Fine, I'll do it. And then we try to talk to him. This is actually should not be while true. This is a mistake as well, actually. This should be like this. So let's make sure that works as well. Still. Telnet. Hello. Hello. Quit. Hello. Yeah, that's working really well. Working really well. Okay. So I think the next step, actually, I said it was to upgrade to an HTTP server, but I think what I want to do now is actually like hide Epoll, right? I'm a fan of basically when you like pull in dependencies in general. I know that like Epoll is like not really a dependency, but when you have like something that you might not use for all of time or like for like the duration of your project, it's kind of nice to like hide that thing from the rest of the system so that it doesn't leak, right? If we are going to like say let's like give an example. Say I want to use this event loop to handle HTTP connections. And I want to like register with our event loop and say, hey, when I get TCP data, I want to do this thing. If I do that by using the Epoll file descriptor directly, and later I find out that Epoll has some deficiency and I want to use poll instead, which would be a backwards maneuver, right? Let's say that we implemented it with poll instead of Epoll and we want to upgrade for speed. Or maybe we find out that we can like implement this whole concept with IOU ring, which is like way faster and way better. Or maybe we go onto a new system, we go onto like a BSD, and like OpenBSD doesn't have Epoll, it has KQ, and so you would like switch to some other mechanism, right? We want to make sure that like what we do at least like hides the Epollness away to some extent, so that that transition becomes easier. We don't have to support it right now, but like writing it in a way where it doesn't leak means that we won't have to go to every single person who's registered with our event system and fix them. We only have to fix the event system. So I think that's what I want to do here, is I want to hide Epoll from the rest of the system to some extent. So we are at 58:15 into stream. I think that's a good time, actually, to get like a TCP echo server with Epoll. It feels pretty good. Feels pretty good. Okay, so let's make some sort of structure. Const event loop is a struct, and he is clearly going to have like event file descriptor, right? We're working with Epoll, so he's going to look. Oh, sorry, it's Epoll FD. And what else is he going to have? What else is he going to have? We don't really register any other data. Everything kind of goes through the Epoll file descriptor and the like kernel and stuff. So we might not need anything other than this, to be honest. And we're gonna have some sort of like register something. What are we gonna register? So we have like these structures here, and they have an API on them where they have this function that they can be called with their data. And so this is kind of similar to like any generic API, I guess. So I guess them registering this like Epoll data thing, where they say, when I get this when I get notified, call this data in this callback. That seems reasonable. And so maybe we'll say that we take in like a file descriptor that we're working with. So we have a file descriptor, which is an I32. Or I guess maybe we could use std POSIX socket t or something. Fuck it. We'll just use I32. We'll use I32. And we register some event or handler. And so I'm okay with the idea of renaming this Epoll data event handler. That seems like it makes sense to me. And all this does is this. Boom. Yep, so this registers the handler. So this, I guess, means that this has to be a pointer to a handler so that it is valid. And we will just put a note here that handler must be valid for duration of FD. Right? So as long as this file descriptor is registered with the system, then we need to like use this thing. I guess what might be nice here is if this guy returned like something that we could call dinit on, then we could like unregister the handler externally, right? So if you had like something that was like event loop register with like some x and y. Ooh, this is a file descriptor and data. You could do like const handle is equal to this and defer handle d register or something, d in it. Then if you had like data on the stack, then you could pass this in like this, and this would be like totally valid and safe code to run, right? Because we know that before like we go out of scope, we will unregister this pointer with the Epoll system. So I kind of like that. I like that idea. So let's do that. So we'll call this like a registration handle. Handle's fine. And he is going to, I guess, store the file descriptor that he has to unregister. And that's it. Really. That's all he has to store. And we'll just have a pub function dinit. Yes. And this is just going to call, he has to store the Epoll file descriptor as well. Then he can just call this. This is going to call, then event handler should have a dinit function. Let me think about that. I think no, but we will see. I think this makes more sense. So he is going to call self epoll fd, del this shit, and we are going to delete the self fd from the Epoll system. Please get the fuck out of here. This can't be try because of the dinit function. Well, it could be try, but I don't want it to be, so we'll just say catch panic. Failed to unregister with Epoll. This isn't really the best way to do this, but I don't know what else I want to do, to be honest. So this is fine. Because can panic take in arguments? No. Okay, that's fine. This is fine. So this is going to return a handle. Yep. So this is takes in the file descriptor and the event. Std debug panic is formatted. Yeah, we might as well do that. You're right. You are right. Let's at least write down what the error is. I assume that this just like buff prints. Yeah, buff prints. Wait, is that what I saw? Yep, buff print, chillin'. Okay. So we register, we get the thing, then we just return epoll fd is equal to self epoll fd, and fd is equal to fd. Chillin'. Okay. Then I guess we just have a run function on here. So this is going to take itself as a event loop. He might error out. And he's just going to do our while loop. Which means he needs his events storage as well. Which means that we can just copy paste this thing. Yeah, easy. Okay, so now we want to make it so that these things don't rely on the epoll event, but on our event handler itself. So we're gonna have something like event loop is sorry, not event handler, event loop here. And here, instead of calling epoll add here, we are going to say event loop register with the connection. Fuck, where is it? I lost it. Connection. What are our inputs here? File descriptor. So this is connection.stream handle, as well as the connection data. And this failing seems reasonable to me. That seems fine. And then this stuff goes away. Yeah, that seems fine to me. I guess we should maybe also, like, we could like store all of these connections and stuff and free them later. But we'll do that later. Kind of missed the first half of the stream. Are we doing this for the Rube Goldberg machine? Kind of, yeah. So the problem with the Rube Goldberg machine stuff as it's laid out right now is that we handle all of our HTTP requests in like one blocking queue. So as soon as somebody opens a call to us, we reject, we like stall on all other TCP connections, i.e. HTTP connections, until we handle this one connection. And so if they do something slow, like maybe drop the connection without us noticing, or like just like maliciously don't answer us, then all of a sudden everybody else can't talk to us. Even something that's not malicious but is just like innocent, this will just like slow down the server a lot. So we want to be able to make sure that like if multiple people are talking to us at the same time, we can handle that. And so that's where this like event loop system is coming into play. Okay. So we have to fix this guy as well. This guy needs to use the new event loop system. So copy paste, and then this echo, he maybe I guess just wants to contain his own registration handle. Yeah, so this is just the handle, which is event loop handle. And then here, instead of returning this guy, we will say, ooh, this is kind of odd. The order of operations here is really fucked up. But we can do this. We'll say the event loop handle is equal to this. If we don't, I think we just go connection data dot, I guess it's just echoer dot handle is equal to event loop handle. I think that works. I think that all lines up. Yeah. So we just do handle is equal to undefined here. And then this gets set, and then over here, when we finish, instead of calling epoll.ctl, we just say handle dnit. Yeah, that feels like it'll work. So are we effectively implementing async from scratch using epoll syscall? Yeah, exactly. Exactly. I guess calling it async might be a little bit disingenuous. Like, we're not like adding keywords or anything, but we are implementing a system that lets us asynchronously handle many connections in one thread. And by implementing, I mean we are using Epoll, because we're not really implementing the multiple connection stuff. That's all handled for us. We are just using Epoll to build an abstraction around this thing that we can use. Okay, so now instead of constructing Epoll here, we actually kind of want to construct it as part of our event loop. So pub function init is going to return an event loop, who I guess is just going to do whatever we were doing down here. So we constructed an Epoll file descriptor, and I think that's it. Easy. So that means here we are going to create our event loop. Event loop is equal to event loop init, which is failable, so we have to try here. Then we construct our TCP connection acceptor, which uses our event loop internally. He holds a handle to it. This stuff all looks okay. Then here, instead of calling epoll.ctl, we call event loop register. And we register this stuff. We don't need to do this anymore, and we're just going to call event loop run here instead of this loop, because this was copy pasted somewhere else. Yeah, which feels fine. I think everything in here just kind of works. Doesn't compile. It never compiles. A const shouldn't be there, so this is var event loop here. Event handler doesn't like 157, so he found an Epoll event. Oops. So this, we don't need listen event here. We just pass in listener data. He expects this to be variable, but I don't think it should. I think this can be const here. This is fine. Error union is ignored at 152. So this is a try. And we say handle here and defer handle the init down here. Not that it matters. So we have no exit condition right now. Error union is ignored at 154. So this is also try. And he's chilling. Okay. So let's see if it works. Hello. Okay, it's echoing. That's a really good sign. And if we quit and go, oopsies, fuck. We lost Telnet. We lost Telnet. He'll be back though. He'll be back in a second. So we say telnet localhost 8000 again, say some stuff. It is still echoing. So I think we're chilling. I think we are chilling. And API wise, I think this feels okay. So we like manually make some sort of TCP connection acceptor who says, hey, I'm going to register myself with the event loop. Registering things with the event loop is a process of creating a thing we want to register and setting it in. That seems fine. Seems fine. Yeah, and like usage here is also pretty straightforward. We just make an event loop. We give it one thing to deal with, and then we just run it, and it's good. Okay, so I think what I want to do here is I want to make an exit condition. Because if we have an exit condition, then we can test, we can like see what we are not freeing and stuff. We can like run this outer val grid, make sure we're closing all of our TCP connections properly and stuff. So here we need to deinit this guy. Here we probably need to deinit. This guy has no deinit, which is surprising. No surprise, no deinit on our event loop. I guess all he is like an Epoll file descriptor. So we do need some sort of like, self is event loop. We need to Epoll close. Like, how do I get rid of this thing? Man Epoll. What do they do in their example? They just don't close it, which is not helpful for me. Epoll create, epoll.ctl, epoll. Do I just call close? Like, I don't really know if I'm supposed to close a file, Epoll file descriptor. Epoll file descriptor close. Am I supposed to close it? The file descriptor monitor by select is closed. No, I want to know what happens if I close Epoll itself. Clean up Epoll file descriptor. Epoll create cleanup. This is what I want. Returns a file descriptor, so you just use close. Perfect. That's what I wanted. That's what I wanted. Wrong window. It's open here. So we just call stud POSIX close on Epoll FD. Chillin'. Chillin'. I guess calling this close might be, Dean, it's fine. Because we don't really, it's like, when you have a file, we call file close because it's working on a file descriptor and that's called close. But in this case, like, you don't really know from the external perspective that event loop is based around a file descriptor. So calling it close might be a little confusing. We're calling it dinit is like pretty clear. This stuff feels okay. Is there anything we have to do? TCP connection acceptor. So he probably will have to clean up all of the connections that he's created. So he's going to have spawned a bunch of files and created a bunch of TCP echoers. And I guess technically this TCP echoer should like kill himself in some way, right? He should be like, when I'm done, I will free myself. So does that make sense? Who is responsible for the lifetime of this guy? Because there's kind of like two cases here, right? One is that the program ends and it is time for somebody to clean up everybody who hasn't, like, all the TCP connections that haven't been closed yet have to be cleaned up. I wonder if it makes sense for our interface to have like a dinit function. Is there a way to like enumerate things that are registered with an Epoll file descriptor? Right, because like what's happening is we have like a TCP connection, and we have TCP echoer. Both of these guys are like created and like fed. I guess it's what TCP echoer has a TCP connection, and then the echoer is like kind of fed into like Epoll. And so there's like two things that we could do here. If Epoll lets us enumerate all of its data, we could maybe like pull out this thing and like dinit him at the end of the lifetime of the event loop. When this guy is like, hey, I've closed my connection, Epoll doesn't really know that he cares about that. So he kind of can like close himself. I think that makes sense. And so then it's just a question of, say that he doesn't decide to close himself, whose job is that? Because the other option is that it's the like listener. And the listener kind of like keeps a reference to all of these guys, which would mean that TCP echoer would have to keep a reference to listener as well, because he would need to say, hey, listener, I'm done. Don't worry about me, bro. I fucking figured it out. And so if we can like destroy this connection by like iterating Epoll and just saying like, I'm going to close anything that's left over, that would be kind of nice. But I suspect that that's not an option. But we could track that externally. Yeah, it does feel like he doesn't really keep track of those things in a way that's exposable, or that's exposed to us. Okay. Let's do it here. I think this makes sense. So the TCP connection, he makes connections and he destroys connections. So he'll just kind of say connections is array list of studnet server connections. And his echoers is a bunch of TCP echoer. And so on his dnit, he's going to have to iterate over all of these. So for echoer, he calls echoer dnit. Oh, this guy doesn't. No, he just frees it. So he calls self alloc destroy echoer, which means that this is actually this has to be pointers. Since echoers have the connections, why not make echoers close the connection? Is that what I want to do? Yeah, we could do it that way. That feels like it might work. So then we say echoer dnit here. And then here, this guy also has a... Maybe we just do this. Here's what we do. We'll kind of abstract this away. So we'll say, I have some sort of init function here that returns a TCP echoer. That feels okay. So he takes an allocator, he returns a pointer that might fail. His dinit is responsible for freeing himself as well as closing the connection. So he'll just call a self alloc destroy self as well as self connection close. Really? No close here? dinit, sorry. Then here we will do, I guess, this stuff. So he's going to say, allocate me with an echoer and a connection, I guess. And then he will store this allocator, and he'll return echoer. Then this is a little odd. This is a little odd because he needs to like get the event loop handle. So maybe we will call this like, do we like just register this right now? Like to the event loop? I don't know. Oh yeah, he needs the event loop handle here as well. Yeah, I guess we've taken the event loop here. No, I don't really like that. I don't like it. Maybe this gets like nulled. And this starts as null. And maybe on dinit, we also dinit the handle if it's something. That feels like it might work out. Maybe. So we have handle, we dinit the handle. Then we have like function register with the event loop. And then we say, we do the stuff. Yeah, that feels okay. That feels okay. So here we just say self connection like this. We have to create our connection data, which is this. Yeah, so this stuff goes down here. Boom, 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 boom. Yes, yes, this feels like it works. This feels like it works. Data is self. And then self dot handle is equal to this. And here we just register with the event loop. Yeah, that feels nice. And then up here, we just call const echoer is equal to self echoer, nope, TCP echoer, initialize with this allocator and this connection. Then we error defer echoer dinit. Something goes terribly wrong. This, I guess, probably has to be variable. And then we just say echoer register with event loop. That feels like it works. That feels like it works. Maybe. And then this feels pretty clean here at this point. Okay, so when we make this guy, we need to say that, like, we append this echoer. Yeah. And I guess we do this before we register it. Yeah, so we try here, and then we say, if we fail this, we pop him back off. And then I think that any failures here end up being like handled automatically, which is pretty cool. This connection we don't have to worry about now. Yeah, seems fine. This is try, I guess. This is a little odd. If this fails, then the connection won't close. So I guess here we actually have to do some like custom error handling where we say connection. Is this not dinit? It is. dinit here. And then return E. Yeah. Yeah, okay. That feels okay. Does it build? Surely this doesn't build. Missing echoers at 167. So here, echoers is stood array list TCP echoer init alloc. Terror, thanks for the bits. Appreciate it. Appreciate it. Very kind of you. No function named dinit in connection? Is there not? Am I high? Connection. Oh, stream. Is it connection stream? Connection stream close. Which means that probably down here it's stream closed as well. And then I guess here we shouldn't call self handled unit, we should call self dinit. Value type ignored at 28. It's okay, we don't really give a fuck about that, so we'll just put a little underscore here. Okay. I guess we should make sure that everything is still working without like crashing. Because there's a good chance I fucked something up, but it looks okay. Oh, here, aborted core dump. Here is what I was worried about. So here, epoll CTL deleting this thing at handle dinit at self dinit is failing. So this is at line 79. This is not working. Epoll CTL deleting self.fd is no good. Why? Oh, because I closed it. So here, this has to go in this order. Probably. Probably? There we go. Yeah, now he's happy. Now he's happy. Because by closing the file descriptor, epoll automatically unregisters himself. Which is pretty interesting, and maybe I should just abuse that. Nah, because we don't really know. If we change the implementation later, it's not like clear that that's going to be the case still. So I think that's fine. Okay, so now we need to make sure that we can like break out of this thing in some way. So maybe we will add a function, a variable here that's like running. I don't really like that, but or shutdown. And I guess we'll just say here like self shutdown is equal to false. Actually, no, we'll just say while not self shutdown. And then we'll make it so that if the echo server hears someone say exit, he'll just set that field. So we can say here, if buff 0 to red bytes is the same as exit, like this, can we self.event Fuck. I only have a handle here. We'll just do this. We'll just do this. Fuck it, you know? So register self event loop is equal to event loop. Uh-huh. And then we will say self event loop shutdown is equal to true. So now when we see the word exit, everything should exit cleanly. And then we should be able to test if all of our stuff got cleaned up correctly. Which would be nice. Would be nice. Okay. So here we'll telnet. We'll type some stuff. We get some stuff back. We'll quit. We'll do another thing. Oh, fuck. Telnet. And we'll say exit. That didn't work. That did not work. Which is surprising. I thought it would. Stood debug print. Exit time now, please, man. Like, is this doing... Oh, maybe there's a... Fuck me, man. Telnet? Does it send the new line? That's my suspicion as well. That is my suspicion as well. Oh, alright. We will actually log what we get. Got this. And we'll put it in even some quotes that we can tell. Buff 0 red whites. What have we done wrong? What have we done wrong? Exit. Maybe there's a /r on there as well. Could be a /r on there as well. Because telnet, I think, might do that by default. Yeah, there we go. Okay, and now we have a bunch of stuff that isn't freed, which is good. So connection data was not freed at event loop zig 56. So here we made a connection data, and this is part of TCP echoer. So this is when we register this thing. Oh, which means that we should store that thing. So that we know to get rid of it. So here we'll just say self connection data. Connection data. We do this at the end because it is error deferred here, so we will just only put it or give it to ourselves for dinit later if everything works. And then over here we'll just say if self connection data like this, we self alloc destroy connection self connection data or data. I guess it should happen after dinit technically. Not that it matters, this is all single threaded, but you know, just in case. He doesn't like that because 45 is missing. Connection data is equal to null. My language server died. Little bug, no big deal. Let's try this again. Exit. Okay, what else? What else is he not like? Missing at 58. We construct this thing. Wait, did we fix this? Did we not? Maybe we're just not calling this dinit. That's possible. We are not. Maybe. No, we should be calling it here on TCP connection acceptor dinit. Do we calling that? No, that would do it. Yeah, let's try that. Telnet, hello, exit. Okay, there's a lot less now. We are missing an array list dinit at data callback data. TCP echoers append. So at line 27, this thing. Are we not dinitting them all here? Oh, oops. Oopsies. Okay, So now we can do what was it? Telnet in. We type hello, quit this, telnet again, type exit. Okay. Another bad file descriptor. So handle dnet, echo error dnet. Oh, fuck me. So if we dnet ourselves, we have to unregister ourselves from this TCP connection acceptor. Which sucks. Yeah, that's annoying. It means that like this guy needs to say like connection acceptor. And then he would have to be like loop over all of these things, all of these guys, and if he's this one, remove himself from the list. Which doesn't really feel like the right abstraction, to be honest. Is there a better way? Is there a better way? I'm not really sure. So all of this stuff, I guess we could move this to... Let me think. Echoers set. Yeah, I mean, that's a little, like, that's fine. I'm more worried about, like, the, like, intertwining behavior of these two guys. I want to know if there's, like, I'm trying to think to myself if there is a better way of abstracting this stuff so that, like, the TCP echoer and the TCP connection acceptor are, like, more independent from each other. But maybe it's fine that they are pretty intertwined. I mean, also, let's just keep in mind as well, these two example things where we're just making a TCP echo server, these don't really matter, right? It's more that I want to make sure that like the API to the event loop doesn't force shitty classes, right? So if there's like a behavior here where it's like, oh, this stuff will always happen this way, maybe that we want to like put something in the event loop to kind of fix itself up, right? Right, so we could, right, like theoretically, you could do something like registered handlers here, right? And when we register something, we could push to the registered handlers. Yeah, you could give it, you could like put this like register, you could put a handle to this thing in the returned handle here. And then when we did this, it would like maybe in here call a dinit function. Right? And then no, like this guy doesn't have to keep track of all the things he spawned because they'll dinit themselves. Which would like make this guy kind of have to hold less data. And then that also kind of makes it so that when we register something with this thing, we don't have to like keep track of it afterwards. We kind of just like let the event system own it at that point. And if we don't want to let the event system own it, we just give it a null dinit. I'm kind of okay with that. I'm down to try that. So before we do that though, let's just make sure that we still build. So it was registered handlers. So we'll get rid of this. And let's we just want a checkpoint so that we can revert back if we horribly fuck ourselves. Because I don't think we've checkpointed anything so far. Event loop checkpoint. Yeah, so let's make our event system have a bunch of things that he's tracking. So handlers is a stood array list event handler. Okay, and What that actually kind of lets us do, maybe, is does that let us change our like Epoll implementation to give like an index to the handler instead of the handler's address itself? Because if he owns the handlers like this, then we can't just provide a pointer like this. That's sketchy. Sketchy, sketchy, sketchy. Because when this array list resizes, then the pointer will move. Think. I don't think so because this is a pointer here. But I wonder if you could like thinking. So first of all, we can't give it a pointer to ourselves because we are not guaranteed to live on the heap. Which means that this array list is kind of in a spot where it's not really guaranteed to live on the heap. Okay. What are our options for our data field here? U64, U32, I32, and usize. So we have 64 bits of data to use. I guess for each file descriptor, we could do an allocation, which we kind of were already doing. Segmented list for pointer stability. That doesn't sound crazy. Let me think about that a little bit. I mean, I think that what I want is... What is the usage of this again? Yeah, I guess the Epoll thing doesn't need... All it needs is the handler. And we could... There's two options here. We could make these guys pointers, double in direction, which is fine, not the end of the world. Or we could make these guys this, and somebody said segmented a list. So I assume that this is a list that we can append to, and when we append to it and it needs a reallocation, it will like... Okay, hold on. We'll draw it. I'm assuming that it's something like this. So you have like items 1, 2, 3, and 4, or 5. 1, 2, 3, 4. This one's empty, right? We go, okay, we push a fifth thing. Great, it's there. Then we push a sixth thing. No room in the array. We'll allocate a new one, and we'll go 6, question mark. This stuff isn't filled in. Then we fill this one up, 7, 8, 9. Then we run out of room again, and we create a new one. That's what I assume this is. Although I guess that like removing stuff from that would be a problem. You would need to like keep track of the empty slots. That kind of sucks. I would rather just use like... Let me think. Yeah, I think that I prefer just storing a bunch of pointers here. Then if we store a bunch of pointers, we don't have to worry about like indexing or anything. We can swap and pop these things without losing track of where they are, at the cost of like an extra allocation on registration. But I think registration should not be happening frequently enough that it's a problem, right? I think that's probably an okay trade-off to make for now. Who's calling register again? So sometimes right now these things could live on the stack. So here we're going to kind of assume, we'll say for now that these are unowned pointers. Unowned pointers. And we are just using these handlers to call dinit on them. So when we unregister something with this handle, do we even need this? Hold on, thinking. Beep, boop, beep, boop. What problem were we trying to solve? I think we do need this because we need somebody to own the fact that we need to call dinit on everything that's been registered. Okay. So I think that this gets a little complex. I think we can store like an ID to this thing. Fuck me. So if we store a list of all these guys, when somebody calls deinit with this handle, we need to remove from handlers list as well as call deinit. And this is the part, remove for handlers list gets a little tricky, because like if you were to just do like array list, right, of these guys, then you could just swap and pop, which would be fine, except for all of the handles that are out in the world would like lose track of which one is which. Say this guy stored a handler. You could maybe get away with this guy calling handler deinit and then also just like ripping the array to find the pointer that matches. That's not fucking crazy. That's not crazy. Yeah, we could do it that way. We could do it that way. Fuck it. Fuck it. So this calls handler deinit. But this thing doesn't exist yet. So we'll call it deinit, which is a like function that takes in data. So this is an any opaque. Yeah, so an optional function that takes in an any opaque and returns void. Then if it has it, we call it with handler data. This is also unowned pointer. Yeah, so far so good. And then we just remove this from the handlers list. So for self event loop handlers, if I guess we want to go I dot dot 0 dot dot, sorry, and then we say if handler is equal to self handler, we say self handler event loop handlers swap remove I, and then we break. Boom. Boom, boom. I guess maybe we swap remove then deinit. That's probably just in case. I mean, I guess like thread safety doesn't really fucking matter here. Everything's on one thread anyways, but I think that works. And here we also have to say if self handler has a deinit function, then we call that function because it might not be said. Okay. Does this still build? 142. He's missing a handlers thing, so we'll just say this is stood array list initialize or of event handler initialized with some allocator. Which means that we need an allocator here. And on deinit, we have to say self handlers deinit as well as iterate over all of them. And if the handler has a deinit function, we have to call it. Yep. Yeah, I think that makes sense. Won't pointers still get invalidated when the list grows? But if the pointers are unowned by this, then the pointers, like, it's not a problem. Right? The pointer to the event handler, if it was like this, would get invalidated, but if it's like this, then it's fine. I'm pretty sure that that's okay, but we'll see. Okay, so on init, we need to give it an allocator. And then on 139, we're chilling. Okay. And then we're missing some deinit things. So at 213, this listener data thing is going to have deinit is equal to null, I think. Okay. because this is getting called unconditionally here. And then there's probably another one of these guys somewhere. Somewhere. No field epoll fd on handle, so 169. This is here. We are constructing ourselves with some hand from ourselves. So we have, would you say, what does this guy have? He has a event loop is self. And then he has a file descriptor, which we still use, and a handler is equal to handler. Okay, that should be chilling as well. He doesn't like that it's immutable, but I think that it's fine. Just write const here, and then it should be fine. Missing field dinit at line 60. So that is here. We have a registration function, and on dinit of the echoer, this was the motivator for this thing. When we dinit the echoer, I don't know. We'll figure it out. We'll figure it out. I can't remember exactly what problem we were trying to solve, but I know that this fixes it. I want to fix this stuff and then figure it out in a second. 123. This also needs dot items. And then we had swap remove at 129. So here, just ignore this shit. And epoll fd does not exist at 134. So this is event loop dot now. Okay. And now we can just run our thing again and look for our motivating case. Oopsies. Telnet. Hello? So it was that we quit one, and then we typed exit? That's where we got our problem. So this is from something deinitting twice. Right. So the problem was that we didn't want our TCP connection acceptor to have to log all of these guys and deinit him. That was our motivating case. So let's fix that. And figure out where it goes. Okay, so he's missing. Echoers does not exist. And telnet. Hello. Quit. Telnet again. Hello. Exit. Now we have a bunch of memory that we did not free from the TCP echoer thing. So what we want is we want to say, hey, when we register our TCP echoer, we are giving you some fucking ownership of this guy. And so we will say here, you can free me. Yeah. And I guess this is going to be like, we'll have like an opaque dinit function, which is just the same as this. We'll just like call ourselves, I guess. So it's like function f takes in any opaque, and he just does the pointer cast to self is equal to pointer cast align cast data, and this is turning myself into a TCP echoer, and then I can also self dinit like this. And then here I just pass f here, or opaque dinit. That's what we called it. I think that's right. Echoer, we'll call it. Okay, and so now if we run that same test again, we should be able to telnet in. Right, hello. Kill this connection. That's segfaults. There's a double dinit happening somewhere. A double dinit, almost certainly. Almost certainly. Where? I guess we'll look at the. We'll just GDB it. Dun, 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 dun. Telnet, hello, quit. So I see. I see. Uh so this is going back and forth between 128 and 53. So I just made a fucking stupid ass mistake somewhere. 128. So this is in the D init function here at event loop. And 53. Right, so he's saying, oh yeah, that's pretty funny. That's pretty funny. So when I fuck me. This is so confusing. So I have a TCP echoer and I'm saying, hey, at some point I want to call myself fucking done. And at that point, I should just not call self dinit, but I should call self handle dinit. That will call self dinit, and then everything kind of just works. And then this just should only be called through the handle, which kind of means that here, I kind of want this function to almost not exist, to be honest. But I think I call it on error here, which is like pretty fucking reasonable. Okay, this is fine for now. We'll try this just to make sure that like fixes the fucking crash. Hello. Hello. Quit. Quit. Fuck. Seg fault still. Where is this coming from? What have I done? I've done something like fucking stupid. So here we are calling event loop dinit at frame event loop run from echo. We dinit ourselves. He is mad at a seg fault in here. Interesting. So what is seg faulting? P self event loop. Oh, event loop is dead. Why? What the fuck? So in TCP echo, I'm calling event loop handle dinit. So in function echo, I'm calling handle dinit. From the event loop. This calls self event loop some stuff, and the event loop is apparently invalid memory. Is it possible that handle is invalid here? Telnet, hello, quit, frame 1, p self handle. Whoa, that's invalid too. Oh, my whole self is invalid. Okay, that's a good clue. So this is not good, which means, did I like fuck up my deregistration? Did I fuck up my deregistration? So here, when I dinit this, I delete my connection. Ah, this has to be in this order. It's the same problem that we had before, where we have to unregister ourselves before we dinit, maybe? Because maybe this is getting called. No. Maybe. I don't see why that would be the case, but we can try. Oh, oops, I didn't rebuild. I didn't rebuild. I don't think this is it, to be honest. Oh, but it does look okay now. So maybe it was. Hello. Hello. Quit. Yeah, it does feel okay now. Okay. And then let's test. We need to make sure that we don't like leak memory anyway. So let's run this. We say hello, quit. Tell that in again. Hello. And we type exit now. And then he quits and he is leaking some memory still. Okay, so what have we fucked up here? On registration, we create an event handler. We create a TCP echoer. This TCP echoer, when he is created, is not freed at event loop 32. Am I not? I'm supposed to destroy myself in this dnet function. This is not called. And on dnet of the, oh, am I not dnetting the event loop? I am here. Does this guy have a dnet on him that I'm not calling? No. Does this guy? No. What am I fucking up so bad? When I register this guy, oh, that would do it. I'm supposed to register him with the handlers. Append. The handler. And I guess if we error out, we pop it. Yeah, let's try that. Let's try that. Fuck. Expected type that found that. So this we can just write const here and everyone's happy. Fuck. Expected that found that, probably because I forgot to write const somewhere else as well. Here, write const. Okay, he's chilling, and then we will try hello, exit, telnet in again for a second action, hello, exit. Boom, baby, let's go. Okay, so all of our memory is correctly freed. And how do we feel about this API in general? How do we feel about it? This feels definitely okay now, right? This TCP connection acceptor is like very simple, right? He just says like, hey, I have a new connection. Let me like make a new event that I want to register with the event loop, and we will do that. This registration with the event loop is like a little complicated, but it's not the end of the world. He has like a dnet function on himself that should not clean up this handle. So does this handle even? Yes. Okay, so there's like kind of like some sort of like confusing back and forth here, where the dnet function should not call handle dnet, but because the handle dnet is going to call into our dnet, which is like the flow there is a little bit confusing, but it's not awful. It's not awful. There's like an argument to be made that this dinit function should be like hidden away somewhere. And then we could make it so that here we could do something like error defer echoer or alloc free or destroy echoer. And then in here, no, that's not very clean either. Not very clean either. Okay. That's fine. That's fine. Not the end of the world. We'll just note in here. Intentionally not calling handler dinit because it is expected that handler dinits us, not the other way around. Does that feel fucking stupid? Maybe what we should do instead. Oh, here's what we can do. This will make way more fucking sense. If self handler handle, we call hdinit. Otherwise, we do this. Nope, that doesn't make sense because then we won't actually do it. Never mind. Okay, I'll have to think about this a little more. But I think other than this little oddity, I think it makes sense for us to keep track of our event handlers. And I think like the deinit method on the handler makes sense. I think there's just like a little piece that needs to be sorted out. We didn't get to running this like an HTTP server through this. I think that probably there's enough there to come back at this tomorrow. Because I think that like the adapting the Zig HTTP server to like work correctly with this will be a little bit of work. So I think we will come back and do this tomorrow. So thanks for watching, guys. If you liked what you saw, we stream most days at around 2 o'clock Pacific time for around 2 hours. Right now, we are kind of working on the long-term project of our Rube Goldberg machine, like a collaborative Rube Goldberg machine. So the idea is that we're writing a server that runs some physics simulations. Users can upload WASM modules that will run physics on the server as well as like rendering on the client. And we'll like stitch together all those WASM modules to create one big simulation, which will be kind of fun. Right now, the subtask is getting this like event loop working, but there's more to come. So feel free to swing back by if you want to check that out. If you're watching on YouTube, there should be a Twitch link in the YouTube description. If you're watching on YouTube, there should be a Twitch link and a GitHub link in the Twitch descriptions. Litmarv, thanks for the bits. Appreciate it. Yeah, I think that's it. Like, subscribe, Twitch Prime, and bye YouTube. Well, Twitch, let's figure out who to raid.